Okay, so today's lesson is about writing formulas and giving names to molecular compounds. So you have to be able to tell if it's a molecular compound or not. And remember, the first page of your note goes over how to tell the difference. If you look at this page again, last time we discussed ionic compounds, and you know they're ionic because the metal is first. Now we're doing molecular compounds, and you know they're molecular because you have only non-metals, like sulfur and oxygen are both non-metals. They are to the right of the stair step, so everything to the right of the stair step is a non-metal. And to the left of the stair step are your metals. Okay, so back to the page we were on. You have to know the difference between an ionic compound and a molecular compound because the rules for naming them and writing the formulas are different. As you can see here, when it's molecular, we use prefixes from 1 to 10, mono to deca. These prefixes are very similar to the ones you use in geometry, so you should still know what all those mean. Okay, but molecular compounds are not made of ions, and we don't crisscross charges because there are no charges if it's not ionic. And we will only work with binary types of compounds, so we don't have to worry about polyatomic ions either. There are no ions. And that means, though, that all of these will end in IDE because that is the ending given to anything that's a binary compound, IDE. But the first element's name does not change to IDE. It is still just what you find on the periodic table. So this is carbon, and this is oxygen, but we would change oxygen to oxide. Okay, but you probably know this better as carbon monoxide, and that's where these prefixes are coming from. When you have an element in a compound, and it's the first element, and you'll have only one, then typically we don't write the mono for that. Okay, so it's not monocarbon monoxide, it's just carbon monoxide. Okay, so let's write that down. Okay, so also you'll notice that the name of this compound is that oxygen starts with an O and mono ends with an O. So when we have two vowels together like that, we leave off one of those vowels. So I'm going to write over here when you leave off a vowel. Okay, so what this is saying is that when your prefix ends with an O and your element begins with an O, we leave off the O for the prefix. So monoxide instead of monooxide. And also some of these end in A's, and when you have two vowels together like that, typically we get rid of the vowel that the prefix ends with. So if you have an A next to an O, then we would just get rid of the A. Okay, so if we look at the second example, it shows you that you have two oxygens and one carbon. So we don't crisscross our charges, and that means we don't crisscross our names either. If the 2 is with the oxygen, then di is with the oxygen. You don't cross it over to the carbon. Okay, so, and again, there's one carbon, so it would be monocarbon, except this is the first element, so we leave off the mono of the first element. So this is carbon dioxide. Remember, it ends in "ide." Every single one of these will end in "ide." Okay, then our third example here, now we have sulfur first, and it's not going to be sulfide. You don't change the ending to "ide" on the first element. It stays just as its name is on the periodic table. So this is sulfur, but then oxygen turns to oxide. So sulfur dioxide. Okay. Sulfur dioxide, again, it was repeated here, don't worry about that. Let's start here. So we have one sulfur and 3 oxygens. Prefix for 3 is tri. So let's put their names together. Okay, the next one has 2 nitrogens and 4 hydrogens. So di is for 2, tetra is for 4. So we put those prefixes in front of each of the names of the elements. And remember, we change hydrogen to hydride. Okay, so the next compound has 2 phosphorus and 5 oxygen. Prefix for 2 is di. The prefix for 5 is penta. So diphosphorus, it's not diphosphide, which is a common error, right? Because you only change the ending of the last element. So diphosphorus pentaoxide becomes pentoxide. Okay, in our next compound, we have 1 phosphorus and 5 chlorines. So phosphorus pentoxide. I'm sorry, pentachloride. Okay, so our next one has 1 sulfur and 6 fluorines. So the prefix for 6 is hexa, and we change fluorine to fluoride. Okay, and then finally 1 phosphorus, 3 chlorines. Prefix for 3 is tri, and we change chlorine to chloride. Okay, now let's try going the other way. We have the name, and we're going to turn that into a formula. So you have to know what all your prefixes mean. Tetra means 4, so I have 4 chlorines and just 1 carbon. You don't crisscross either. If the tetra is with the chloride, then that's telling you you have 4 of those, not 4 carbons. Okay? The next compound, dinitrogen. Di means 2, so we have 2 nitrogens. Monoxide, mono means 1, so we have 1 oxygen. Okay, so I'm going to pause the video, or you should pause the video and try the rest of these on your own, and then push play when you think you're done so you can check your answers. Okay, so here are your answers. I do want to point out that this was a typo right here. TIR should be tri instead of tier. That means we have 3 sulfurs. Okay, I hope you got those right. And then our next lesson, we will start here with naming acids.